Hello, my name is Lucas de Queiroz Lima,
Hello, my name is Junior Marques Moreira.
and we are Os Metelão.
Hi, we're gonna show you how the GUI is working. The first section developed for the GUI is the normal image section. In this section, the user can choose which image is gonna be used as the base image. To do it, the user must enter the name of the image on this campus. The image that we're gonna use in this example is the image given, that is the dog image. So, inserting its name and clicking on the button load, we can get the image as shown up below. The second section for this GUI is the hidden image, where the user can choose between all the images that he wants to hide, the one that we're gonna be using. So to do it, you must do the same thing as the another section. Just insert the name of the image that's gonna be used. That in this case is gonna be the hidden tree. Load the image, and then the image is shown. So the user have the options between which embed method are gonna be used by to hide this image. You can use the odd, even, red embedding, 1, 2 blue embedding, and 3, 4 green embedding. In this case, you're gonna use the 3, 4 green embedding. So the image shown on the uh, below the word preview is the image obtained with the after the embed method applied. So the user have the option to discard this image or to save it. We're gonna discard it and make the embed method on the odd even red embedding method. So we're gonna save it now with the name testing, and now we have the file with the dog image with the hidden O3 image inside it. Now to recover the hidden image, the user must enter on this section embedded image the name of the image that we just obtained, that is testing, and press the button load to get it, and choose between the three recover methods which one we're gonna be using. As we use the odd even red embedding to hide, we must use it to recover also. So pressing the button, we can get the hidden image back. Now we're gonna show the two functions developed for this code. The first function is the flatten image function. The goal of this function is get the image that will be hidden and make it a binary, transform it to a binary image. So to do it, first of all, we need to get the size of the matrix of the image. So we get the number of rows, the number of columns, and the number of layers of the image. That as it is a RGB image, gonna be 3 the number of layers. After this, we build a matrix called BW binary, which is a two dimensions matrix with zeros in all elements and have the same number of rows and columns that the image to be hidden. So entering a for loop, we can make on this BW binary matrix by entering number 1 for the pixels that has less or equal 150, or letting 0 for the pixels that has more than 150, and then we can build this BW binary matrix. Now we're going to show you the expand image function. The expand image function gets the binary image and transforms it to a RGB black and white image. To do it, first of all, we need to get the size of the binary image and associate the number of rows to the variable A and the number of columns to the variable B. After this, we define a new variable called BWRGB, which is a matrix of 3 dimensions with zeros in all elements with the same number of rows and columns than the binary image variable with 3 layers. So using a for loop, we can make all the elements from the BWRGB equals 0 for the positions where the binary image is it's equal 1, and for the elements of the binary image that are equal 0, we can place a 1 in the BWRGB.
So now I will show you the GUI code, the steganography.m. That is the first tag that collects the file name of the normal image. This other tag named load1 is associated with the normal image. The third tag collects the file name of the section hidden image, and then the load2 tag is associated with the hidden image. The embedding one is the first embedding type. This is the odd even red embedding, that in the red layer of the RGB image you turn this odd when it's black, and you turn the number even when it's white. So this is the second method of embedding. Is the tag is embedding 2. We call this method 1/2 blue embedding because in the third layer of the RGB, the blue layer, when the number in the binary is black, we've made with the number of the position ends with 1, and when the image in the binary is white, we made with the value of the in the position of this new image to end with number 2, and then we show the image here. In the third type of embedding, we call that 3/4 green embedding, that puts in the second layer of the 3D matrix the value in this position will end with a 3 if the corresponding position in the binary image that we are trying to hide is black, and we turn this number ending with a 4 if in the corresponding position in the binary image is white. So that's the discard button. If we can use that if we want to change the image that we are trying to hide in the normal image. This is the save button, that you can save the image with a hidden image inside in your computer. This is the tag edit free, that collect the embed image that you want. Load free, the tag is associated with the embed image. This is the first method of recovery, is associated with the odd even red recovery, and you find the odd and even numbers, and whenever the number is odd, you turn the position, the value in this position 0, that makes the image in this point to be black, and when the number is even, you turn this position to be white, and then you create a binary image associated with the first image that you hide in the normal image, and then you show the image right here. This is the tag recovery 2, that is the second recovery method, is associated with the 1/2 blue recovery. That's this do the same thing that the last one, but he trying to find the numbers that ends with 1 and turn it black in the binary image, and search for numbers that ends with a 2 and turns in white. Recovery 3 is associated with the 3/4 green recovery, and do the same thing, but you search for numbers that end with 3 and turn it black in the binary, and search for numbers that end with 4 and turn it in white. So you expand the binary and you show the image, and that's how the steganography GUI works.